All right, folks, let's dive into some layout stuff here for a little bit. So, first thing I want to emphasize is to keep it simple. In my experience, the first adequate solution is usually not the most simple or cost effective or easy to build. So, once you get to a satisfactory solution, keep going and see how simple you can make it. Analysis software, design, or drafting software can do really complex things these days, but that still doesn't make up for the fact of something just being complicated. So as you go through your design career, not kind of, but train yourself to find the elegant, simple solution. And it takes time, it takes patience, it takes rework, but it's definitely worth it. Okay, so I've repeated some information that we went over in the Intro to Structures class. Basically, what are some common span ranges for different systems, to kind of give you a feel for what is possible. Beams don't go forever. If you're going to go further with concrete, we need to do something different than just post and beam. Here's a material advantage matrix, and then a structural system advantage matrix. So depending on what you're trying to accomplish or what your building needs to emphasize, you can look at these two matrices and get some insight into what makes sense. It's worth the time at the front of a project to really understand why we're choosing certain systems, and a lot goes into it. Material availability. If you're building in Houston, the nearest aggregate pit's 500 miles away, so it doesn't make sense to do extensive big concrete buildings there, maybe for the foundations, but not for the superstructure. Um, so anyway, there's reasons for each choice, and I would encourage you not to rush through it and really think it through. And those may include conversations with other design team members, with a contractor if one's been selected, and definitely with the owner. All right, some common physical dimensions for different types of buildings. It doesn't mean these have to be this way, but they tend to be dimensions that work well with things. Taking a look at a parking garage, you'll notice a common dimension in the short grid dimension is 18 or 27 feet. That's because most parking spaces are 9 feet wide, and 18 and 27 are multiples of 2 and 3 of 9. So generally, as you lay out a building, you'll lay it out based on what the function is, and there may be some core things that go on in that building that really push the grids to be a certain way. Okay, some construction types. Cast in place, or CIP, is what we'll really focus on in this class. Precast, where it's made off site. Here's a picture of a precast garage. And then post tension, where the concrete's poured. Tendons, you can see the anchorages of the tendons here are pulled, and you put stress into the concrete the opposite way gravity loading will. All right, lateral systems, the main two types are concrete shear walls and then moment frames. They both have their advantages and disadvantages. Post and beam precast, you can see these haunches receive the beams, and then the beams receive these either T's or planks that are precast. These buildings can be built off site and shipped and then thrown up pretty easily. The disadvantage to precast is the connections tend to be embed plates with welds, and in high seismic zones, those don't tend to perform very well. Okay, so as you get into your building layout, it helps to have a feel for spans. How deep does something need to be for a given span? So if I have a one-way slab 10 feet long, I need a minimum of 5 inches. Have a beam that's going, say, 30 feet, I'm going to be a minimum of 24 inches. So this kind of table is great when you're at the early stages of a project to establish the basic framing depths. It helps set floor to floor heights. Architects always ask, well, how deep does this beam have to be to go this far? And a table like this can be really helpful. And if you give it to the architect, then they don't even have to ask you the question. All right, some column preliminary designs. Basically, I built this based on square feet, tributary, um, and then number of stories. So, 16 stories, 10,000 square feet were pretty healthy column. Okay, so I've added some steps on how to do this. I would say the first thing when you're laying out a building is to start with the column spacing. And a lot of times that's going to be developed by the architect. If you're doing an industrial project, there'll be a general arrangement drawing where someone has laid out the equipment or the function of the building and then established grid lines from that. From there, rather than select the beam spacing, I like to see what the slab thickness options are. So I can come back to this table here and get a feel. Okay, if I have 10, let me put these two slides next to each other. So I can say, if my grid spacing is 25 feet, what's that, 30 feet, so that the way these beams are drawn would be a 15-foot. That gives me an 8-inch slab. Well, maybe that's thicker than I want. Maybe the contractor has really asked us to minimize the slab thickness for whatever reason. So I come here and say, oh, 5-inch slab can span about 10 feet. I can come here and put my beams, double up my beams based on, as opposed to what I've got here. So the main thing to think about is this thing's iterative. It's not a linear progression from I choose one thing, I do the next thing, I do the 500 items down, I'm done. There's a lot of coming back. And rather than being rigid and firm about things, just kind of take it easy and be open-minded about how things might work. But do it with good data. And data like this, maybe some other quick hand calcs, can really help us develop our framing in an intelligent way. All right, lateral system. This is going to be something that, again, is iterative with the architect. If we use any lateral system that blocks large portions of the building, then that really becomes a coordination thing with the architect. So if we chose shear walls or we choose shear walls, that's going to take more coordination on a project than moment frames. But there might be great reasons to do that. So some suggestions when you're laying out a lateral system, I'd say first just keep an open mind and be creative. Something's better than nothing. If the architect will give you half a bay of shear wall or a bay of shear wall with an opening in it, that's better than no shear wall. If moment frames are the way to go, then maybe you work out some drift detailing with the architect so you can push the code drift limits a little bit. So anyway, as you basically lay out a lateral system, just stay open-minded about things. Okay, so on this next page, and we'll do this more in class, I want you to go through and lay out the gravity system for this fictitious project. Or if you want to do that for your own project, which you'll need to do anyway, go ahead and start laying this out as to where your beams and columns and slab spans are going to be. So maybe starting with a column grid, you're going to have beams on the grid lines because that's how things work the best. And then really it's a matter of figuring out what are the filler beams and slabs looking like in here. Same sketch for lateral system, deciding how you're going to lay out the lateral system of this building. Some people may want to keep everything on the perimeter and maybe just do something like this where they've got a couple shear walls, like maybe like that. I would encourage you, if you have a big jog in a building, to at least add shear walls on those free edges, and you can be creative here. If that blocks like a great view for an office, say the mountains are up here or the ocean or something cool to look at, maybe you pull these to the interior or back over to here. Lots of options. You could even do something like this where the shear wall is on the interior of the building and you can have a fairly large opening that you could walk between, this space and this space. So anyway, get creative. Moment frames obviously would look like this without those walls and would create a lot of flexibility, a lot of visibility to the outside, but they tend to be a little more costly to build, and the drift can be an issue. But don't shy away from moment frames because they're fantastic and they have some serious advantages when it comes to robustness for progressive collapse or things like that. All right, so coming up pretty soon, you have your layout drawings due, and so use this PowerPoint, use the preliminary design stuff. We'll talk about it more in class. And basically, for this submittal, you'll develop the general framing of your building. But as the semester goes on, you'll really dial that in. So don't feel like this is the end or has to be everything.